In this video, I'll show how to use the GoDirect voltage and current sensors to investigate simple circuits, an activity that's common in physics and physical science courses. I have here a simple series circuit consisting of 2 batteries and 2 light bulbs connected in a single continuous loop. When I connect this final lead, I'll complete the circuit and electricity will flow. In a circuit like this, I'd usually like to be able to measure the potential drop across a light bulb and the electric current through the circuit. While I'm setting up my sensors, I'm going to disconnect this final lead so I don't discharge the battery too quickly. The GoDirect voltage and current sensors can both be used wirelessly via Bluetooth wireless technology or wired with a micro USB cable. Because circuit labs can easily become a jumble of wires, today I'm going to connect my sensors via Bluetooth. First, I'll turn each sensor on. At this point, the sensor's Bluetooth LED is flashing red, meaning that it's available to connect. Next, I'll open the graphical analysis app on my device and choose Sensor Data Collection. From the list of discovered wireless devices, I'll choose my GoDirect voltage and current sensors. I know these particular sensors are the ones in front of me because the ID number matches both on the sensor and in the software. One thing to note here is that both the voltage and current sensors have 2 measurement ranges. The GoDirect voltage sensor can measure electric potentials or voltages over a range of 0 to 20 volts or 0 to 1 volt. The larger range is usually what you want, especially for circuit labs like we have here. If you expect to measure potentials less than 1 volt, say for instance you're measuring the induced EMF in a coil of wire, you can get greater resolution by choosing the smaller range. To do so, you would tap or click on the sensor channels option in the software and select the smaller 1 volt range. If you choose this range and you end up measuring greater than 1 volt of electric potential, the measurement in graphical analysis will max out at just above 1 volt. In that case, you'll likely want to redo your experiment on the larger range. The GoDirect current sensor also has a smaller measurement range for experiments that involve currents on the order of tens of milliamps. To change the measurement range on the GoDirect current sensor, you move the physical switch on the sensor rather than select a different sensor channel in the software. The range switch on the sensor is labeled plus or minus 1 amp for the larger range and plus or minus 1/10 of an amp or 100 milliamps for the smaller range. For most electric circuit investigations, you'll want to be on the larger range. If you notice that your current measurements are maxing out around 1/10 of an amp, the range switch is probably in the smaller range position. For a battery and bulb type investigation like I have here, the default range settings, 20 volts for the GoDirect voltage sensor and plus or minus 1 amp for the GoDirect current sensor, will work well. Now that I'm connected to the sensors in graphical analysis, I'm going to switch from the graph view to the meter view. I'll do so by clicking on the View button in the upper right-hand corner of the window and choosing Meter. In a simple circuit setup like this, when I connect this final lead and electricity begins to flow, the voltage and current won't change in the circuit. I like the meter view for this kind of investigation because it makes it easy to read the measurements from the sensors. Before connecting my sensors, though, I'll want to zero them. You can do this by connecting the leads to each other and clicking on the live readout and choosing the 0 option. I'll do the same for my current sensor. When you first turn on a sensor, it'll likely read close to 0. If it reads slightly off, any subsequent measurements will likewise be off. Zeroing the sensor allows us to avoid these sorts of systematic errors. Now that I've zeroed the sensors, I'll connect them to my circuit. The GoDirect voltage sensor should be connected like any other voltmeter, in parallel or across the circuit element you wish to measure. Set up like this, I'll measure the voltage drop across this light bulb. The GoDirect current sensor should be connected in series with the other circuit elements in your circuit so that the electricity in the circuit flows straight through the sensor. In this case, I'm actually going to replace this final lead with the sensor. I'm now ready to connect the final lead and complete the circuit. As you can see, we're now measuring the voltage drop across this light bulb and the current through the entire circuit. In an investigation like this, I might compare the voltage across any individual light bulb or across all of them to the voltage on the battery. I might look at how the total current through the circuit changes as I add or remove light bulbs. Or I might rearrange the connections between the circuit elements to compare series to parallel circuits. One final note for using these sensors: where you clip the leads matters. The GoDirect voltage sensor measures electric potential drops relative to the black lead. So if the voltage increases from the black lead to the red, you'll see a positive voltage measurement. If it drops, you'll see a negative voltage measurement. For instance, if I switch the leads as they're connected to this light bulb, you'll see that the measured voltage has changed in sign. Likewise, the GoDirect current sensor reads positive when the electric current flows in through the red lead and out through the black lead. If you switch the leads, the sign of the current measurement will likewise change. The GoDirect voltage and current sensors are great for a variety of electricity investigations. For more information on how to use them or to find labs to use them with, visit the website.